You open a browser, click that little spy hat icon and feel a small sense of relief. Private mode, incognito, whatever your browser calls it, it feels like a force field, but it is not a force field, it is barely even a curtain. Most people who use incognito mode believe it hides what they are doing online. They are wrong in almost every way that matters. Your internet service provider can still see every site you visit. Your employer, if you are on a work network, can still see every request you make. The website you are connecting to knows your IP address, your browser fingerprint, and exactly what you clicked. Incognito mode solves exactly one problem. It does not save a local history file on your device. That is it. That is the whole feature. In this video, we are going to take incognito mode apart and look at what it actually does, what it does not do, why the gap between perception and reality is so large, and what the tools are that actually provide the privacy most people think they already have. Let us start with what incognito mode genuinely does. When you open a private browsing session, your browser creates a temporary profile that is isolated from your main profile. Cookies set during that session are not written to your permanent cookie store. Your browsing history is not appended to your local history database. Form autofilled data and passwords you type are not saved. Downloads are not logged in the browser download list, though the files themselves do land on your disk. When you close the private window, all of that temporary session data is discarded. If someone sits down at your computer after you, they cannot open your browser history and see where you went. That is a real and useful privacy property. It is just a very narrow one. Now let us talk about what incognito mode does not do, because this is where most people have a completely incorrect mental model. The moment you type a URL and press enter, your browser sends a DNS query to resolve that domain name into an IP address. That query goes to a DNS resolver, usually one operated by your internet service provider. Your ISP logs that query. They know you looked up that domain, they know the timestamp, they know your account. If you are in the United States, ISPs are permitted to sell that data to advertising brokers. Incognito mode does nothing to prevent any of this. After the DNS query resolves, your browser opens a TCP connection to the web server. That connection passes through your ISP's infrastructure. Even if the connection is encrypted with TLS, the destination IP address and the server name indicator, which is a field transmitted in the TLS handshake before encryption begins, are visible to anyone operating network infrastructure between you and the server. Your ISP sees it. Any network-level observer sees it. Incognito mode does nothing to prevent any of this either. When the request reaches the web server receives your IP address. Your IP address is not a secret. It is a routing requirement. The server cannot send data back to you without it. The server also receives your user agent string, which describes your browser name, version, and operating system. It receives your accept language header, which specifies your preferred language. It receives your screen resolution via JavaScript if the site runs any scripts at all. It receives your time zone, your font list, your installed plugins, your GPU render string via WebGL. These dozens of attributes assembled together form a fingerprint that is statistically unique for most users. That fingerprint is the same whether you are in incognito mode or not, because it comes from your browser and your hardware, not from stored cookies. Cookies themselves are interesting. Incognito mode stops third-party tracking cookies from persisting after your session ends. But if you log into any website during that session, that site knows exactly who you are. Google knows you are you the moment you sign into Gmail. Facebook knows you are you the moment you open Facebook. Every action you take while authenticated is attributed to your account, regardless of browser mode. And even without logging in, fingerprinting alone is sufficient for a determined tracking company to re-identify you across sessions. There's a concept called a supercookie or evercookie, which stores identifier data in a dozen different browser storage locations simultaneously. Local storage, IndexedDB, cache timing, e-tags, even the CSS visited link color history. Incognito mode clears the obvious ones at session end. It does not necessarily clear all of them. Researchers have demonstrated persistent identification across private browsing sessions using timing-based techniques that require no storage at all. If you are on a corporate or school network, the situation is even more exposed. Many enterprise networks operate a TLS inspection proxy, sometimes called an SSL intercepting firewall. Your machine is provisioned with a trusted certificate from the organization. When you make an HTTPS request, the proxy terminates your TLS connection, reads the decrypted traffic, re-encrypts it, and forwards it to the destination. The organization sees your plaintext requests. Incognito mode is entirely irrelevant here. The privacy boundary is the network edge, not the browser. So what actually provides the properties people think incognito mode provides? The first tool is a VPN, a virtual private network. A VPN routes your traffic through an encrypted tunnel to a server operated by the VPN provider. From the perspective of your ISP, they see one encrypted connection to the VPN server. They do not see which sites you are visiting. The destination site sees the VPN server's IP address, not yours. This shifts the trust problem rather than eliminating it. You are now trusting the VPN provider instead of your ISP. If the VPN provider logs your traffic or is subpoenaed, the protection evaporates. A quality no-log VPN with independently audited logging policies provides meaningful ISP-level privacy. A cheap or free VPN often provides less privacy than your ISP. The second tool is Tor, the onion routing network. Tor routes your traffic through 3 volunteer-operated relay nodes, encrypting the payload in layers. Each node decrypts one layer and forwards to the next. No single relay knows both who you are and where you are going. The exit node sees your destination but not your identity. The guard node sees your identity but not your destination. This architecture provides strong anonymity against network-level observers. It is much slower than a VPN and it requires care. Logging into an account over Tor immediately relinks your traffic to your real identity. Exit node operators can read unencrypted traffic. The third layer is DNS over HTTPS or DO8. This encrypts your DNS queries, so your ISP cannot read them at the query level. Your queries go to DNS resolver over HTTPS rather than in cleartext over UDP port 53. This closes the DNS visibility gap, but does nothing about the destination IP address or SNI fields that remain visible at the network layer. For local device privacy, which is the problem incognito mode actually solves, disk encryption is the more robust answer. If your device is encrypted, an attacker with physical access cannot read your history even if you forgot to use private mode. Full disk encryption on a locked device is a much stronger guarantee than a browser mode that depends on the user remembering to close the window. Browser fingerprinting is harder to defeat. Tor browser addresses it by normalizing the fingerprint of all users. Everyone using Tor browser reports the same screen resolution, the same font list, the same user agent. You look identical to every other Tor browser user, so the fingerprint ceases to discriminate. The Firefox Resist fingerprinting option attempts something similar in a less restrictive environment. Extensions that randomize or block fingerprint attributes provide partial protection but can themselves become a fingerprint signal if they are sufficiently unusual. The real lesson here is about mental models. Incognito mode was designed to solve a local physical access privacy problem. Someone borrows your laptop, someone uses your shared family computer, you want to buy a gift without it appearing in autocomplete suggestions. For that problem it works well. The misperception that it provides network-level or tracker-level privacy comes from the name. Words like incognito and private imply a scope of protection those features were never engineered to deliver. Every network request you make is a series of disclosures. To your ISP via DNS, to network infrastructure via IP routing, to the destination server via the request itself, and to any intermediaries operating on that path. A browser mode that clears local state after a session touches none of those disclosures. The data never stops flowing. Incognito mode just stops your own device from writing it down. That is browser privacy and why incognito mode is not what most people think it is. Thanks for watching.